Good morning, Wenjing. I'm Cheng from the Group F. Here's our video of the packet tracer. To ensure the sequence of the topology and complement graph configuration logic, I will explain the green part, and Jinghao will explain the blue part. Huaran will explain the purple part. So let's get started. This is our Cisco packet tracer. Let's get started from the beginner. To configure the device setting for routers and switches, the first step is configure host names as per partial topology diagram. Let me show you. This is the host name config, and this is the host name block inlet, host name Fishman Road, host name Southern Western Highway, and host name Clark Island. Well, in the beginner, the banner and MOTD is welcome to Group F. And I will insert the password Cisco. And enable. And the password class. And I will show the running config as an example for the command field. Here is the host name config and the same command as the block inlet, Fishman Road, Western Highway, and the Fish Island, Rock Island. Now, second part is the password Cisco for console connection. Here is this is the password Cisco for console connection, and the encrypt the private EXEC mode using the password class. And here is the class, the password class. And this is for the service password encryption. And the next step is show the disable domain name server DNS lookup. And no IP domain lookup is the disable domain name server lookup. And the next step is the enable login sequence for console connection and all virtual terminal lines. And this command login synchronous is the enable login synchronous for the console connection and all virtual terminal lines. So this is done, and I will show you configure the interface of routers and host as per the topology diagram and your addressing table B and C. And this is our group F table B and C, the final version. As the same example in the chem field. Those command is for all the, this command is all the type logic diagram from my addressing table B. As the same as the other routers. And this is all the address in the block inlet. Is the same, is all the same from the table B. And this is all the address in the Clark Island. All the address from same as from the table B. And in the table C, you will see the PC1, PC2, PC3, IP for address, subnet mask, and gateway. This is the PC1 address. EC2 address, and the PC3 address. So these big two parts are done, and I will require the following network verification to be accessed. I will explain these two parts: verification of the device's basic configuration and verification of the correctness and functionality of the interface configurations. Let's get started. Still the example for the COM field. And we will first step, I will show you step by step. The first step is verify the host name. This confirms that the host name is correctly set according to the typology, making devices identification easier. The command is sorry. Well, this confirms that the host name is correctly. The host name is ComField. And I will copy the requirements as the same as the other routers. And the next step is verify the console and the VTY password. We check in this command, verify command, we check if login passwords are set for the console and the virtual terminal lines to prevent an unauthorized access. The next step is verified enable secret is the privileged EXEC mode password. where the enable password is success. We ensure a secure enable secret password is configured for entering privileged EXEC mode. And the next step is a verified password encryption. And services password encryption is success. This confirms that password encryption is enabled, protecting plain text credential in the config field. And the next step is the verified DNS lookup is disabled. Well, this command, we will check the DNS lookup is disabled to avoid delays when incorrect commands are entered. Well, the next step is verified SSH is enabled for security remote access. In this part, I will show you the SSH input. Access the Clark Island through the SSH. So we will command promote in promote in the PC1. And I will. The password is Cisco. Welcome to group F enable. Password class. Oh, and we use the SSH into the Clark Island from the PC1. And the final step is to configure message of the day MOTD banner. And the final step is verify the MTD and banner. Here's the banner MTD is the welcome to group F. And this command is a banner MOTD. Welcome to the group F. It's as the same as the other routers. For now, we finished the verification of the device's basic configurations. And the final step is the verification of the correctness and functionality of the interface configurations. In this part, I will follow the table B. I will use the compute to pin the block inlet and clock inlet, clock island. In the compute, I will pin the block inlet. It's can pin successful. And the next step, I will pin the clock island. The clock island is well, it's same as a success. The final step, I will check the interface status. Well, we are ensure that each interface has the correct IP and is in the all in the up state. And we pin the test, confirm that interfaces are properly configured and functional across all the routers. So in my part, I have finished my part. Thank you for watching.
Hi, Professor. I'm start to do my presentation, and this is our topology and about our group study case. There are three parts I have finished. The first one is config VLANs according our switch and VLAN table, and second is config the management VLAN SVI interface. And the third one is config static and OSPF routing. And the three verification about my part. Okay, the first about the config VLANs and the trunking. I config VLANs on both two switches. On Fishman Road switch, I create VLAN 10 for project, 20 for HR, 30 for security, 99 for management, and 555 as native VLAN. And then I assign the port FA03 to VLAN 99 for my PC, and also config port FA01 and 02 as a trunk port, which allows VLANs 10, 20, 30, and 99. Just use the command like this. Yeah. And then I do the same thing on the Southwestern Highway switch. And the part 2, I configure VLAN 99 interface SVI on both switches and on Fishman switch. The IP address is 10.0.53.50.352, and on Southern Western switch, the IP is 10.0.53.53, and the default gateway is 10.0.53.49, which is on the router broker inlet, and this lets me remotely manage the switches. I just use the command like this. Yeah. Don't forget the no shutdown and the IP default gateway. And the third part is router. And the third part is the config traffic and OSPF routing. And in this part, on the router and the inlet router, on the broke inlet router, I create 4 sub interfaces. Is FA 01.10 and dot 2 dot 20 dot 30 and dot 99, and that means for VLAN 10, VLAN 20, VLAN 30, and VLAN 99, and each subinterfaces use .1Q encapsulation for VLAN routing. And I use a command just like this. And then I configure routing the static and the OSPF. On the CAMField router, I set up 2 static routers. The first one is IP routing 0000, a lot of 0, and 209, 165.200, and .233. And the second is 0000, a lot of 0, and 209.165.200.237, and 100. And the first is a main default route, and the second is a backup with distance 100. And all router also use OSPF. Yeah, like this. And this help routers learn internal routes automatically. Okay, this is my configuration, and the next part is verification. Okay. The first verification is VLANs and inter-VLAN routing. Okay. I will use the goal of this verification is VLANs are created correctly and ports are assigned to correct VLANs, and trunk links are active, and inter-VLAN communication is working via router on a stick. Let me use some command. For switch. Okay, because my group member have already set the password, and he will show them, so I don't input them here. Yeah. First, I will use the show VLAN brief. Yeah. I use the show VLAN brief, show VLAN 10, 20, 30, 99 with correct ports assigned. And this means VLAN configuration is success. we can see here XSS, and then I use the command show interfaces trunk. Yeah, this command shows trunk interfaces FA 023. Oh no, it's not 23. FA 01 and FA 02 with allowed VLANs 10, 20, 30, and 99, and native VLAN 555. And then this main VLANs can travel switches. And then I use the command show IP interface brief. Okay. Yeah. This command means it shows sub-interfaces with correct IPs, and they are up status. You can see here it's up, 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 up. Yeah, correct. This means router can route VLANs. And we also can use the ping function. Pin PC2 from PC1. Here is PC1 CMD, so we pin PC2. PC2 is 10.0.52.3. Yeah, it's successful. The inter-VLAN routing is working. We also can pin PC1 from PC2, pin PC1. Yeah, successful. Okay, the part 1 is finished. The next verification is about the dynamic routing for IPv4 or SPF. The goal of this verification is OSPF neighbors are discovered and the routes are exchanged between routers dynamically. Oh, sorry. I forgot to do the same verification for the another switch. Let me do it first. Successful and show interfaces. Okay. Yeah, successful. Here. Active. Yeah, correct. And show IP interface brief. Yeah, up. Okay, correct. Oh, correct. Okay, we move to verification 2. It's a dynamic routing for IPv4. And I will use 3 commands. The first one is show IP or SPF neighbor. It shows neighbors with router ID, interface, and state. And the state should be full. Let me see. From the config first. Okay. Show IP OSPF neighbor. Yeah. The state is full. And this means routers are exchanging hello packet. And then we show IP route. Oh, a lot of things. And show IP route, this command shows routes with 0 prefix coming from other routers. Yeah, you can see here. This means, okay. This means this router is come from the OSPF to get it. And then I to subnet located computer show them. Yeah, here is a CAN field router, so we can from the CAN field turn pin pin Clark Island, look back. That is pin. Yeah. Yeah, it's success. This means this pin is success, so it shows redundancy if multiple SPF has appeared for the same level. Okay. And we can do the same thing in the Clark Island. Enable it. Class show IP or SPF EIG HBOR. Yeah, this data is full. And we show IP router. Yeah. Yeah. Okay. And in this enable class. Yeah, it's full. Yeah, it's all. So it show it is get it from the OSPF. The OSPF routing table is populated. Okay. And we can come to the next verification. And the third verification is about static routing for IPv4. And the goal about this verification is static default routes are configured correctly, and the ISP router has returned the route, and the backup route works when primary is done. So first, we use the command. Let me see. Yeah, we can use the command in the CAN field router. We show IP route. We use the show IP route, and we can here ACE star. Yeah, ACE star. It means and this means it's the main connect. And we also use this command show running config. And by the way, the ACE star means this is a static router. And the 0000 means all the unknown object. And this means it's the next main ISP interface. Okay, let me show the show run, do the run show running config. Okay. Yeah. Here we can see the first one is the main and the second one is the backup. And this number is 100. This show running config command shows both static routes. The first one is main, the second one is backup. Okay. And then we can ping the outside look back from the PC3. We pin the outside look back from PC3. Yeah, we pin 1.1.1.1. Okay, it's successful. So it means the look back on ASP is successful. The static route in use. And the internal network can reach public addresses. And then we can shut down. Let me see. Config terminal. Config terminal. Interface FA0 0. And we shut down this interface. Okay. That's it. Great. Then we show IP route. Here we can see the ACE star is via 209.165.200.237. It is a backup address, so it's correct. And it shows a new default route is correct. This is a for over test, confirm fault tolerance setup, it works. Okay, that's all. Thank you. It's all about my presentation.
Hi, Professor. I will start my presentation now. I will demonstrating the configuration of the host PCs, the net setup, end-to-end connectivity verification, and the failover behavior of redundant links. Okay, so the first, these are all my part. Okay, so the first PC1. PC1 is a network administrator's PC connected to management rely on the Fishman root switch. And its IP address is 10.0.53.51. And this is subnet mask. And this is default gateway. And this one is PC2. PC2 is a part of Project Relay on the Southwestern Highway switch. And this is IP address subnet mask default gateway. Okay, and for this one is PC3. PC3 is any backup server located in the Clark Island City. And this is the IP address, subnet mask, and default gateway. Okay, for question 2, I will do configure net. And our team both overload net and static net to allow internal users to access the internet and make PC3 reachable. Our group both overloaded net and the static net to allow internal users to access the internet and make PC3 reachable. Okay. So our group configure both overloaded net and static net to allow internal users to access the internet and make PCs reachable. So the first step we define internal address using ACL. And the second step, we configure net overload on external interface. And the third step, we assign net roles to interfaces. Okay, in the end, this maps the private IP for PC3 to a public address for external access. Okay, so now I will show you the net verification. First, and then show IPNet statistics. Okay, we should to. Okay, so that's all right. And now I will show you the end-to-end connectivity testing. First, we do PC1 pin PC2. All good. The second, we do PC2 pin PC3. Sorry. Okay, that's all good. And next, we pin to variety ISP reachable. Sorry. Yeah, all can pin. And the last one, we do verification of the redundant links. First, we do show IP OSPF neighbor. And we can see two neighbor. Second, we do show IP route. Okay, next we'll do the show IP route. The third step we do the simulate link failure. Like first configure. And the interface. Oh, sorry. The next we do interface and then remember shutdown. Then we return. Okay, all good. Now I finished all my parts. Thank you, Professor.